Hi, my name is Angie Oswald and I am a student at Western Governors University, and this is my presentation on towards finding a cure for type 1 diabetes. I'm going to tell you a story about a little boy named Jeremy. In 2003 he was 6 years old and he was suffering from excessive thirst and having really bad headaches and wetting the bed, and his mother, assuming that he had a bladder infection, took him to his pediatrician. And after doing some testing on him, the pediatrician came into the room and told his mother that he was type 1 diabetic. So immediately he was rushed to Primary Children's Hospital, which is a local children's hospital, and they began treatments for him with insulin. Little did the family know that this would be a dramatic change in their lifestyle, beginning with blood glucose monitoring, counting carbohydrates, and with daily insulin injections. For many years, little Jeremy got down on his knees and prayed that one day a cure would be found for his type 1 diabetes. Could he ever receive an answer to this prayer? With all the advancements in medical technology, great strides are being made every day to find a cure for diabetes. There are millions of children all over the world who are suffering from this chronic disease. More than 13,000 children are newly diagnosed every year here in the United States. This form of diabetes is believed to be an autoimmune disease and affects the pancreas. Patients can learn to manage their illness by constant blood sugar monitoring with a meter, or living a healthy lifestyle, and by use of an injected hormone called insulin. Although great advances are being made in the lifelong management of diabetes, is there really any hope for ever finding a permanent cure? There are many parents and children who are waiting an answer to this question. So what exactly is type 1 diabetes? Type 1 diabetes is a condition that stems from a failing pancreas. In a more normal body, the pancreas produces a hormone that is called insulin. As the stomach and liver transform the food we eat into glucose, a form of sugar, the pancreas begins to produce insulin. In the bloodstream, the insulin helps to convert this glucose into energy that is used by all of the cells. In the body of a diabetic, the pancreas, which is right here behind the stomach, fails to produce insulin. If the glucose remains in the bloodstream without being converted, it becomes like a poison called ketones. If these ketones build up, they can be very harmful to the organs, and such as the heart and the liver, and can be even fatal. So in short, insulin is the pathway for the sugar to pass from the bloodstream into every cell in the body and is essential to human life. So why does the pancreas fail to produce insulin on its own? Experts aren't exactly sure why the pancreas quits working. They believe that there is actually a genetic predisposition for this, even though there may not be anyone else in the family who has the disease. Those who have this predisposition are then exposed to a virus or some other agent in the environment. This virus goes in and attacks the pancreas, which sets off the immune system, who attacks the healthy beta cells, mistaking them for the virus. Once attacked, the beta cells in the pancreas discontinue producing insulin, and it renders the pancreas actually useless for producing insulin. As a result, it becomes imperative that the body receive insulin from an external source, such as injected insulin. Taking into consideration that so many children have type 1 diabetes and the severity of the illness, we ask ourselves a question: what is being done to search for a cure for diabetes? During the 1980s, doctors began testing the idea of pancreatic transplantation as a cure for type 1 diabetes. That means transplanting the entire pancreas. Originally, these transplants had an extremely high rate of failure, which has improved over the years, but not extremely. Since 2003, scientists and doctors have begun pursuing different avenues of possibilities of transplantation, but not of the entire organ, just the insulin-producing beta cells. The hope is that they will be able to restore the pancreas's own ability to produce insulin. As of 2007, this experimental procedure has been tested in about 1,000 patients, although this seems promising, many patients have had to have more than one transplant, and most of them have had to resume daily insulin injections. The reason for this failure seems to be caused again by the immune system attacking the newly implanted islets, which contain the healthy beta cells. Through trial and errors of previous studies, scientists have been compelled to rethink the implantation process. Because of the relentless immune system attacks on the pancreas, researchers are looking at ways to actually fool the immune system. There was a study in 2007 done that was conducted on 15 newly diagnosed type 1 diabetics. This procedure involved giving the patients chemotherapy and to eliminate white blood cells that were attacking the pancreas. Then the key to this whole study, though, was that the patients had to have at least a small amount of healthy beta cells still remaining in the pancreas. The doctors took these remnants of beta cells, removed them, treated them, and then replaced them back into the bloodstream. The diabetic symptoms in these patients actually were reversed, and they no longer needed insulin injections. Although this study sounds like a cure, most researchers are reluctant to call it that because the studies are still in the infancy stage. The results have not been proven how long patients will be injection-free, although some of them have been injection-free for 35 months and for others for 12 months. A promising article in the February 2008 New Scientist magazine reports that a team from Novacell, which is a stem cell engineering company in San Diego, have successfully treated mice with type 1 diabetes using insulin-producing cells from human embryos. The main reason that they chose mice to use in this study was because the mouse pancreas is close to the human pancreas. These insulin-producing cells were injected into the abdomens and the backs of mice whose islet cells have been destroyed. When they subjected these mice to high sugar meals, the beta cells actually began working and producing insulin to counteract the high sugar in the blood. Although research seems really promising in this area also, the cells need to first be modified before they can be used in humans. It is also possible that once transplanted in a human, these cells will actually again be attacked by the immune system. So Novacell is also working on a form of a polymer coating that will make it possible to actually hide the cells from the immune system. Studies in this area are still ongoing. The race for a cure for diabetes does not come without a huge financial cost, but the benefits may outweigh the costs. Annually, millions of dollars are raised by research foundations such as the American Diabetes Association and the Juvenile Diabetes Research Foundation. For example, in 2007, the American Diabetes Association alone raised over $42 million towards research to combat both type 1 and type 2 diabetes, as well as complications of diabetes. With all of the ongoing research throughout the world, hope still builds for these children, and that we will be able to find a cure. We slowly unfold new breakthroughs in the dynamics of how the body works every day. New advances in medicine and research are being made continually. There is hope on the horizon for these millions of children forced to have daily insulin injections and for those persistently afflicted with this chronic disease. Little Jeremy may, even in his lifetime, see a day when there will be a cure for his diabetes. And he will not need to take insulin to stay alive. Do I have any questions?
As a concerned citizen, I guess you could say, how can I get involved with helping towards a cure?
That's a good question. Actually, one way you can do that is by contacting one of the foundations, the American Diabetes Association or the JDRF. They actually, the Juvenile Diabetes Research Foundation actually has a Walk for a Cure, and they hold fundraisers such as dinners and golf tournaments, etc., so that they can generate extra funds to help fight the cure for a cure. Are there any other questions? Yeah, you have a question?
diabetes necessarily run in families, or can it be sporadic and just have one member of the family?
There is a greater chance of a family member getting diabetes if there is another family member, but the chances are really slim. As I said, that researchers believe that diabetes runs in families, although it may not have anybody else with